So this exercise is related to the MCQs of topic momentum, topic 1.6. So whenever you see a question related to a topic, recall all the formulas related to that topic. A tennis ball, which is having a mass of 57 gram. First thing, the SI unit of the mass is kg. So even if you see a mass in gram, you have to convert into kilogram. You divide it by 1000. So this will be 0.057 kg, kilogram. A tennis player hits the tennis ball with a tennis racket. The tennis ball has a velocity of 25 when it hits the racket. The tennis ball, when it leaves the player's racket, it is 15 meters per second in opposite direction. The average force exerted by the tennis racket on the ball is 35 Newton. How long it takes for how long is the tennis ball is in contact with the tennis racket? So here the direction change, whenever there's a change in direction, there's always a change in momentum. And for example, this is a tennis racket. The ball was approaching the racket with a speed of 25 meters per second. But it bounced like when it hit with the racket, the ball moved at a speed of 15 meters per second. So final speed is 15 and the initial is 25 because the directions are opposite. So one of them you have to take positive, the other one will be negative. So I always take a first one, initial one as negative, so the final one will be positive. Now, recall the formulas which are related. So we have the formula for the impulse. Impulse is the change in momentum mv minus mu over t. Impulse is mv minus mu, and this is the impulse. And impulse, there's also another formula for the impulse. Impulse is force into time. So one of the formula, impulse is a change in the momentum, and the second one is impulse is force into time. So what we can do, if we combine these two formulas, we can say that because left-hand side is impulse, so we can say force into time is equals to change in momentum. It will be mv minus mu. Now we just substitute the formula, substitute the values. The force is given to us. The force is 35. So we put 35. Time we don't know. The mass should be in kg. So this will be 0.057 multiplied by the final speed, which is 15, minus the mass is again 0.057 multiplied by the initial speed. The initial speed is minus 25. So this negative 25 will be multiplied there. So it will be added. So this will change into 35 into t is equals to 0.057 into 15 plus 0.057 into 12, and then 35 is divided, other side it will be multiplied. So remember, whenever the direction changes, like it change into opposite, you add the two momentum to get the impulse. If the direction does not change, you subtract the two momentum to get the impulse. So 0.057 times 15 plus 0.057 times 25 divided by 35, you will get 0.065. So 0.0649, which is 0.065. So C will be the right answer. Is it clear, this one? Any doubt in this?
No, sir, clear.
Okay. Another question. A metal sphere, whenever there's a collision of the two objects, you will use a conservation of the momentum. What is the conservation of momentum? It states that the total momentum, the sum of momentum before equals to sum of momentum after. So the total momentum before will be equal to total momentum after, whenever two objects collide. So in the question, a sphere X collided with a second identical sphere Y. So there is a sphere X and it collided with sphere Y. The mass of each sphere is 0.15. So this is 0.15 kg. This is also 0.15 kg. Sphere X is traveling at a speed of 2 meters per second. So this was moving at a speed of 2 meters per second. And the impulse of 0.21 Newton second means the change in the momentum. Change in the momentum for Y is 0.21. What is the velocity of X? So say X is there, the mass remains 0.15. Then we have a Y, 0.15 kg. And it moves, it also moves. But what we need the final speed of this one. So whenever object is initially stationary, if the object is initially stationary, the impulse of the object is equals to final momentum, because see, impulse is the final momentum minus the initial momentum. Because if the initial momentum is 0, so it means in that case impulse will be equals to the final momentum. So because the sphere Y was not moving, so what is the momentum of the sphere Y? Because initial is 0, so what is the final momentum of sphere Y? The final momentum means the product of mass and velocity will be 0.21 Newton second. Now, we use a conservation of momentum. The sum of momentum before is equal to sum of momentum after. So what is the momentum of X before collision? So it will be 0.15 times 2, because the mass is 0.15 and the speed is 2, plus for the sum of momentum before collision, before it collide. So for Y, it is 0.15. And what about the velocity 0? Because it is not moving. Then the momentum of the X, 0.15 multiplied by the velocity. So 0.15, what about the velocity? It will be X. And what about the momentum of the Y? The momentum of the Y will be 0.21. Because even though it's given impulse of sphere Y, because its initial momentum was 0, that's why when initial momentum is 0, the final momentum and impulse are equal. Now we'll simplify this. So 0.15 multiplied by 2, that will be 0.3. This will be 0. This will be 0.15x. And this will be 0.21. 0.21 is added, other side will be subtracted. So 0.3 minus 0.21 is equals to 0.15x. Now, when we simplify this,
0.0.
what's 0.3 minus
0.21
0.21?
is 0.09.
Yeah, so this will be 0.09. And 0.09 divided by 0.15.
0.6.
0.6. And so the value of the X, we get 0.6. And we are getting a positive value of the X. So if we are getting a positive value of X, it means X is moving in the same direction as its original one. It means X is moving in the same direction as the original one. If it was in opposite direction, then we will get a negative answer. So the correct answer for this one will be B, that X actually, like X and Y, actually they're moving in the same direction. If we get a negative answer after solving this, then we'll say it will move in opposite direction. Is it clear?
Yes, sir.
Okay. So B will be the right answer. Then we have question 15. An object of mass 1.5 kg is moving at a velocity of 2 meters per second, is acted by the force of 4 Newton. The velocity increases to 5 in the same direction. So direction has not changed, like object was 1.2 kg. First, it was moving at a speed of 2 meters per second. Then the object continued at a speed of 5 meters per second by the force of 4 Newton. We need for how long the force acts. So this is a similar question as we did question 13. We have the impulse mv minus mu, and we also have the impulse f into t. So we can compare these two values. We can say, so it means the impulse will be equals to mv minus mu and f into t. So we can say f into t will be equals to mv minus mu. So force into time equals mv minus mu. So force is 4, time we don't know. The mass is 1.2. The final speed is 5 minus the mass is 1.2 and the initial speed was 2. And this will be 4 into t. So 1.2 multiplied by 5, that will be equals to 6. And this will be 2.4. So 4t is equals to 3.6. So if we need t, so 3.6 divided by 4, so 3.6 divided by 4, that is equals to 0.9 seconds. So A will be the right answer. Why we did not use a conservation of the momentum, like sum of momentum before is equals to sum of momentum after? Because here the object is not colliding, like there's no collision or explosion of the object. If there's a collision or explosion, in that case, we'll use a conservation of the momentum, that sum of the momentum before collision or explosion equals to sum of momentum after. But in this case, it's because it's a single object is there acted by the force. So we need how much time it takes to change the speed from 2 meters per second to 5 meters per second. Is it clear, this one? Any doubt in this?
No, sir.
No.
Yes.
Okay. In question 16, momentum of a body is changed by a force acting on it for a period of a time. Which action increases the change in momentum or impulse? So we have the formula that impulse is force into time, or impulse is mv minus mu. So doubling the force, if I double the force, like force is multiplied by 2 and time divided by a half. So if I increase the force and divide the time, the impulse will remain same, because force will be double, but time is half, so the impulse remain unchanged. Doubling the force, so if we double the force, but we keep the time same, like we're not changing the time. If we double the force, what will happen to the impulse? Impulse will also be double. Halving both force and the time means reducing the force by 2 and time by 2. So impulse will also decrease by 4. And if we halve the force and double the time, the impulse will not change, because impulse depends on force and time. If any one of the factor increases, the impulse will increase. If both are increased, the impulse will also increase. But if we increase one and decrease the other, the impulse will not change if it is done with the same factor. Question 17, 3 situations are listed. An object has a resultant force acting. Object is experiencing an impulse. An object is decelerating. Which situation is the momentum of object is changing? whenever there's a resultant force, there is a change in momentum because impulse is force into time. So if there's a force, there will be impulse. So one is correct. Object is experiencing an impulse. So whenever there's an impulse means the change in momentum. So it means there's a change in momentum. An object is decelerating, even object speed increase or decrease. Like an object was moving at a speed of 10 meter per second, then changes to 6 meter per second. So there is a change in speed. So there is an impulse or change in momentum. So all these cases, there is a change in momentum. If the speed of an object remains constant and no resultant force, it means there is no change in momentum or impulse. In question 18, a ball of mass 0.16 kg is moving forward. So here there's a collision. So whenever there's a collision, what we'll use? We'll use a conservation of the momentum. So here we'll use a conservation of the momentum. That the sum of the momentum when two objects are colliding, the sum of the momentum before equals to sum of momentum after. So momentum before it equals to sum of momentum after. So a ball of mass 0.16 kg. So the ball is there 0.16 kg. It's moving forward at a speed of 5 meter per second. A second ball of mass 0.10 means smaller mass is stationary. Stationary means at rest, not moving, the speed is 0. The first ball strike the second ball and the ball moved for the second ball moved forward at a speed of 0.5. So the second ball, which is 0.15 kg, it moved at a speed of 0.5 meter per second. The first ball, which has a mass of 0.1 kg, 10 kg, move at a speed of 0.5. We need the speed of this first ball, which is having a mass of 0.16 kg. So we'll use a conservation of momentum. This is before. And this one is after. The sum of the momentum before. So it will be the mass is 0.16 and the speed is 5. Plus the mass is 0.10 and the speed is 0. After, the mass is 0.16 and the speed is x. And the mass is 0.10 and the speed is 0.5. Now we solve this. So we have 0.16, the mass, multiplied by 5, that is 0.8. Plus this is multiplied by 0, so it will be 0. Then 0.16x, and then 0.1 times 0.5, that will give 0.05. 0.05 is added, other side will be subtracted. So 0.8 minus 0.05 is equals to 0.16x. So 0.8 minus 0.05, so this will give us 0.75. And this is 0.16x. We need x. So 0.16 is multiplied with x, other side will be divided. So 0.75 divided by 0.75 divided by 0.16, that will give us
4.75.
what's the answer?
4.68.
And actually the speed here, the speed was 0.5. I took it as 5. When I was writing, I think I took it as 5, but it should be 0.5. It's written here. So just we'll change the number to 0.5. So this was by mistake. I took as 5, which is 0.5. This was 0.5. So it will be 0.16 times 0.5. That will give us 0.16 times
It will be
0.5.
0.08.
Yeah.
0.08 minus 0.0.
So this will be 0.08. And then this will
Then
be this.
0.03 divided by 0.1.
So this will become 0.03.
Now the answer is 0.18.
So 0.03 divided by
0.1.
0.16. That is 0.1.
0.19.
Yeah. So this is the value of the x is actually 0.1875, which is about 0.19. So B will be the right answer. Is it clear, this one? Any doubt?
Yes.
Yes, not clear.
No.
Okay. Next question is question 19. So in question 19, what is the relationship between the impulse acting on the object and the change in momentum? Actually, impulse is a change in momentum. So that's, or impulse is also equals to force multiplied by time. So two factors are there, either force into time or change in momentum. In question 20, an object of mass 1.2 kg. Again, this is related to the, it's the same questions which is repeated as we did. So these are the questions related to topic momentum.